Hello everyone, myself Maheshwaran. So this is my ninth task at Need Data for my data science internship, which is earthquake analysis. So here you can see my earthquakes data set is present. So we'll be loading this into our Jupyter notebook and we'll be performing some exploratory data analysis on it. So first I'm importing the necessary packages. So as of now, I'm just importing the pandas alone. So pandas is used for data manipulation and analysis. So first I'm importing that. So after that, under pandas, I have this function called read underscore CSV. So using this function, I can load my data set. So inside this one, I need to pass the location of my data set. So here you can see this is my data set and this is my Jupyter notebook. So since it is present along with my Jupyter notebook, I'm just entering the data set's name along with its extension, which is CSV. So since it is a CSV file, I'm using this one. So if it is an Excel file, you can use different one like read underscore Excel and all those things. So whatever the file is, you can use the function accordingly. So first I'm doing that and I'm storing my dataset under the variable df. So using this head function, I can look at the top 5 records of my dataset. So these are the top 5 records. So first we need to understand the dataset. So first magnitude is the value of the earthquake and location is where it is happened. So and depth is the depth of that earthquake. So MMI is an intensity score that shows how the earthquake has happened and how it affects the people or place in that particular location and all those things. So MMI is the level of the intensity of that earthquake, and notes is some news regarding that earthquake, and event is the it is a unique one like 1948 Ashgabat earthquake. This is a name for it. So event can be a unique one for each and every record, and date is the date at which this earthquake has happened. So this is our data set and these are the columns. So after that, so I'm using this shape function to know the dimension of our data set. So it gives the rows and columns. So rows corresponding to the number of records and columns is the number of features present in my data set. So after that, I'm using this column function to look at the features of my data set, which is the columns of my data set. So these are the columns. And after that, I'm using this function to check the duplicates present in my data set, and I'm using this sum function to sum them up. So from this you can understand there are no duplicate values present in our data set. So moving on to the next one. So using this null sum function, I can look at the null values present in my data set for each and every column. So from this you can understand there are only one null value present under the MMI column and only 2 present under the date column. So after that, I'm using this info function to have some basic knowledge about my data set. So from this you can understand there are totally 76 entities, meaning 76 records. So we already know that, and these are the indexes for them 0 to 75, and these are the columns, and these are the non-null values present in that particular column. So from this itself you can understand MMI has some 75 non-null values, so only one null value, and date has 2 null values, 74 non-null values, and these are the data types of those particular column. So moving on to the next one, using this describe function, I can look at some statistical calculations done for the numerical columns alone. So here you can understand only these two magnitude column and the depth column are considered as a numerical column and all other things are in object data type. So if you want, you can add this function like load equal to the data type like object. So here you can see we have done for the object data types as well. So these are the columns that has the data type as objective. So we have done that, and after that, using this function I can look at the unique values present under each and every column. So moving on to the next part, this is the EDA part. So for this, I am first importing the necessary packages to perform my exploratory data analysis. So these are the 2 packages using which I will be performing them. And this line is to ignore the warnings that my compiler shows. So after that, I'm just looking at the MMI score of it. So MMI intensity is the important one. So this shows the actual intensity of that particular earthquake in that particular location, how it affects and all those things. So it is given in the form of Roman numbers. meaning the levels, I think. So after that, so using this values underscore counts function, I can get the frequency table of that particular column. So this is it. So for this one, I'll be drawing a count plot. So from this you can understand we have drawn a count plot for that particular column. So for this one, we have drawn a count plot. So the first line is to specify the size of our chart, which is 15 into 6 pixels or inches. And after that, so these things will be converted into pixels again, like 15 means 1500 pixels and all those things. And this is the actual part where I'm drawing my count plot. So under sequence, I have this function called count plot. So with which inside that I need to first specify the data set. So data is our df, and x-axis is our column name, which is the MMI column, and this is purely for coloring. So for example, if I'm changing it to blues, you can change the colors. So you can change the color of your bars but just by changing this one. And if I'm changing it to magma, you'll get them. So these are some methods or colors that can be passed inside this palette function. So rainbow is also one among them. So you can see the changes. And for the markings in the x-axis, I'm just making the rotation as 90. So without this one, you can see the markings in the x-axis. So look at them closely. And without them, this is our markings. So I'm just including this one to rotate them by 90 degree. And after that, I'm plotting a histogram plot for the magnitude column. And inside this one, I need this line, which is the distribution line. So for that, I need to specify this one. So this parameter can be used to draw the distribution line, which is kernel distribution entity. And I need to set this one to true. Only then I can get this one. So I'm using this is plot under the sequence for doing this one. And this plt.show function can be used to properly show our graph. So without this one, you can see this is the output of, this is the total output that we get. So with this one, we can get the proper output. So this is our proper graph. And after that, I'm doing the same for the depth column as well. So we have drawn that. And the same for the MMI column. And after that, we are plotting a scatter plot between the magnitude column and depth column. So this is it. And now, same thing, but we are including this function called hue. Enable inside that you can pass a categorical column. So our output will be differentiated based on that categorical. So here you can see they are differentiated based on the MMI column. So this is it, and this is the label for that. And after that, I'm just plotting a line plot between magnitude and depth column. So this is it. This is our output. And I'm doing the same, but this time my hue is MMI column. So we have differentiated them based on the MMI column. So this is it. So this is the legend for it. And now I'm making 3 new columns from the date column itself. So you can just look at the data frame. So this is it. From this column, you can understand the first part is the year, and the second part is the month, and the third part is the day. Based on this information, I'm making 3 columns, naming year, month, and day. So first I'm selecting that particular column, so this one, and in that I'm converting them into string. So after that, I'm splitting them based on the hyphen placed in between them. Okay. So we have done that, and after that I'm sorting the magnitude column based on the values present in it in the descending order, and I'm storing them under the variable df sorted magnitude. So this is it. So based on the magnitude, we have a sorted data set in the descending order because I've set the ascending as false. So after that I'm doing the same for the depth column, but this time we are storing it under the variable df sorted depth. So df sorted magnitude as the data set based on the magnitude value sorted in the descending order, and depth for the depth value. So I'm doing that. So after that, I'm plotting a line plot between the magnitude and year column. So here it is, and all the functions are the same, like line plot and all those things. So after that, I'm plotting a line plot between the magnitude and year, but this time they are differentiated based on the MMI column. So here you can see the outputs are, the graph is somewhat shabby, but this is our output. And after that, I'm plotting a scatter plot between depth and year column. So this is the output, and the same thing is done, but this time hue function is applied for the MMI column. So you can see the changes. This is it. And finally, we are plotting a line plot between the depth and year column, and for the same, but with the hue function applied for the MMI column. So this is the output. So this is a small task that we have done today. This is the end of the task. So thank you for watching. Thank you.